Okay, this is the 7-4 notes. We're going to be talking about arc length and surface area today. This is the formula for arc length. It's basically based on the Pythagorean theorem, a squared plus b squared. We explained this a little bit in class. If you're finding the distance from a point to another point, it's change in x squared plus change in y squared. If you were to scale this down so that you only moved 1 unit over on the x-axis, that means you would only move up delta y over delta x on the y distance, and it would reduce to this formula. That's why this integral works. Now, I believe we started this in class. The way it works is you take your function, take the derivative. This is a simple power rule. Bring the 3 out front, subtract 1 from the exponent. Okay, we get 3 over 6 times x squared, which is going to reduce to 1/2 x squared. Bring the negative 1 out front, subtract 1 from the exponent. This is going to reduce to 1 over 2x squared. Here, all I did was common denominators. Multiply this by x squared top and bottom. This is our derivative. So the formula is the integral from 1/2 to 2, radical 1 plus that derivative squared with respect to x. Now from this step to this one, I'm just going to expand. I'm going to take that x squared minus 4 squared, and I'm going to FOIL that to get x to the 8th minus 2x to the 4th plus 1. If I square the bottom, 2 squared is 4, x squared squared is 4x to the 4th. And you can see already here, I wrote these with common denominators. The only common denominators, or the only common factors, are this number right here, this number right here. If I combine those, I get 2x to the 4th. This top polynomial is factorable. It is actually a perfect square trinomial. It factors into x to the 4th plus 1 squared. The bottom is obviously 2x squared squared, like we had up here. And if you take the square root of that, the square root and the squares are going to cancel. You get x to the 4th plus 1 over 2x squared. Now, we've done problems like this before. Split it up. X to the 4th over 2x squared is 1/2 x squared. 1 over 2x squared is 1/2 x to the negative 2. Using our simple power rules, add 1 to the exponent, gives me 3. Divide by that new exponent. So 2 times 3 on the bottom is 6. Add 1 to the exponent, it becomes x to the negative 1. That's why the x here is on the bottom. And you're going to have to divide by a negative. That's why this becomes negative. Then, just as we've done before, you're going to plug in your 2 first. You're going to plug in your 1/2 second. You're going to subtract those. Now, when you're working on your homework, don't go through all of this work unless you absolutely have to. On the homework, make sure you're able to set it up. On most problems, you can just punch it in, get an answer. Remember, on your calculators, you can hit math number 1. Okay, one easy way to do this is to literally let y sub 1 equal your function. Let y sub 2 equal the derivative. And then you can just plug in the integral from a to b, 1 plus y sub 2, which is the derivative squared dx. See if it comes up with your answer. If it doesn't come up with your answer, then you may have to go through all this work. There is a problem on one of your tests that looks very similar to this. So make sure you refer to this problem when you're working on your test. Let's go to the next page here. You'll notice this one is not solved for y, this one is not solved for x. When you're doing arc lengths, it does not matter if you do it with respect to x or with respect to y. So what I did here was, if x equals 0, you'll notice this work up here. If I plug in 0, I'm going to get y equals 1. Just take the cube root of both sides, add 1. If I let x equal 8, 8 squared is 64. Take the cube root of 64, you're going to get 4. Add 1, you're going to get 5. So if you want to do this with respect to x, you're going to go from 0 to 8. If you want to do this interval with respect to y, you're going to go from 1 to 5. Now, how do I solve this for y? I'm going to take a cube root, or raise it to the 1/3, and then I'm going to add 1. This is the function if I solve for y. If I solve for x, I simply take a square root. See the x squared? I would just take a square root. If I take a square root, I'm going to end up with this function. You're probably asking yourself, why is there no plus or minus? The x values are positive. Since the x values are positive, we don't need the plus or minus, we just need a plus. Now, if I'm going to do this with respect to x, it's going to go from 0 to 8, that interval right there. The derivative of this would be 2/3, bring that 2/3 out front, subtract 1 from the exponent. You're going to get 2/3 x to the negative 1/3. That's my derivative, squared dx. Okay? If you plug this in your calculator, you're going to get 9.073. If I do this with respect to y, I'm going to integrate from 1 to 5. The derivative of this would be bring the 3/2 out front, subtract 1 from the exponent, I'm going to get 1/2. There's my derivative, squared dy. If you punch that in your calculator, you're going to get 9.073. Feel free to pause this video and try both of those. You're going to get the same answer. It does not matter if you integrate with respect to x. It does not matter if you integrate with respect to y. You're going to get the same answer either way. Sometimes one is easier than the other. You have to figure out along the way which one is easier to do by hand. My opinion right now is this one would be easier to do by hand because the radical and the square would cancel. This would be a simple u substitution problem if you had to do this by hand. This one, not so much. This would be x to the negative 2/3. U substitution would not work over here. So if you're going to do this by hand, this one would be the easier one to do. One more problem here on this page. We're going to use our calculators for this one now. How do you do arc length? Right away, you got to take the derivative of your function. Got to still know your derivative formulas. Keep those derivative formulas in front of you. 2 arctangent of x, what's the derivative? It would be 2 over 1 plus x squared. So very simply, the integral runs from 0 to 1, be 1 plus that derivative we just found to the second power dx. And again, punch it in your calculators. Make sure you're in radian mode. Make sure you're in radian mode. And again, feel free to pause the video and give that a try on your calculators real quick. But same thing I said before, when you're working on your homework, don't work it out unless you absolutely have to. Punch it in your calculator, get your answer, especially if it says you can give decimals. Now, the next thing we're going to do is we're going to do surface areas of revolution. If you happen to look at a cylinder, the lateral surface area, in other words, don't include the circles on the ends. Don't include the circles on the ends. The surface area of a cylinder is 2 pi RH. H, think of that as an arc length right here. There's the 2 pi. The radius, we'll talk about that in a minute, how to find your radius, but H is essentially arc length. There's the formula for the arc length. That's why this works. If you're integrating with respect to x, your radius has to be a function of x. If you're integrating with respect to y, the radius has to be a function of y. 2 pi r h. Now, when we did volumes of revolution, if you integrated with respect to x and rotated this way, you had to integrate with respect to x when you rotated around the x-axis or a horizontal axis. If you rotated around a vertical axis, just like the y-axis, you had to integrate with respect to y. That is not true with surface area. You do not have to integrate with respect to x if you're revolving about the x-axis. You do not have to integrate with respect to y if you're revolving around the y-axis. You're going to see either one works here. So if you look at this problem here, we've got a function right there. That function is y equals x cubed. It's on the integral from 0 to 1. 0 to 1. We could also take the cube root, x equals y to the 1/3 from y equals 0 to 1. We're taking that piece and we're rotating it around the x-axis. So how am I supposed to find surface area? Now, if you want to integrate with respect to x, there's my 2 pi. My integral runs from 0 to 1. 0 to 1. Now, what's the radius? If you're revolving around the x-axis, the radius is up and down. It's a y value. Well, what does y equal? Y equals x cubed. And then it's 1 plus the derivative of that function squared dx. The derivative is 3x squared. This would help you find your surface area of revolution. Now, let's say you wanted to do this with respect to y. There's my 2 pi. You would integrate from 0 to 1. But remember again, we said the radius was y. So if I'm integrating with respect to y, x cubed is the same as y. We're going to put a y here for the radius. And then it's 1 plus, take the derivative of that function right there. 1/3 y to the negative 2/3, square it with respect to y. Both of these answers would give you the same surface area. Again, you can pause the video. You can try and punch it in. My advice again is feel free to let y1 equal your function on your calculators. Let y2 equal the derivative. This would be much easier to plug in without all this clutter if you do that. Moving on here, another surface area problem. You'll notice this one we're spinning it around the y-axis. When you spin it around the y-axis, the radius is going to be an x value. Take a look here. The radius of revolution is horizontal. It's x. Now, if I want to do this with respect to x, y equals x squared. The integral from 0 to radical 2, 0 to radical 2. So 2 pi, integral from 0 to radical 2. And we just said the radius is an x value. And then this represents the arc length, radical 1 plus the derivative squared dx. The derivative of x squared is 2x. Now, if you're going to do this with respect to y, there's my 2 pi. How did I get that interval from 0 to 2? You can see it in the picture at 0 to 2. But if you plug in 0 here, you're going to get y equals 0. If you plug in radical 2 here, you're going to get y equals 2. So that's why we're going from 0 to 2. Again, we said the radius was x. You can't put an x here because I need y values. Well, what does x equal? Solve this for x. Take the square root of both sides. X equals the square root of y. That's my radius. What's the derivative of this? Bring the 1/2 out front, subtract 1 from the exponent. There's my derivative squared dy. Both of these questions, both of these formulas will give you the same value if you punch it in your calculator. Again, feel free to pause the video and punch them in your calculator. You'll see they come out to be the exactly same thing. Now, which one of these two would work better if I wanted to work them out by hand? That's 4x squared. If I do u substitution, u would equal 1 plus 4x squared. The derivative would be 8x dx. There's the x dx. U substitution would work very nicely on this problem with respect to x. The y's, it would not be as simple. That would take a little more work. So hopefully you've got the gist of this. If you don't, here are some practice problems that we can work on. How do you find the arc length of this function from 3 to 6? It says arc length, length of the curve. So we're not going to use any 2 pi's. This is not surface area. What's the derivative? Bring the 3/2 out front. That's how I got the 1/18. This function would now be raised to the 1/2. I subtracted 1 from the exponent, but don't forget your chain rule. Got to multiply by 18x. That's the derivative of the inside. The 18s will cancel, and I get x times 9x squared plus 6 to the 1/2. So how do I find my arc length? I integrate from 3 to 6, 1 plus that derivative squared dx. And again, just like I told you before, if you're working on your homework, once you set this up, punch it in your calculators. Watch your parentheses here. Again, I think it would be easier if you set y1 equal to this or y2 equal to this. Creates a lot less clutter. See if you come out with 192. Feel free to pause the video and see if you get that answer.